This is the fractal flame we are going to build. It's called elliptic split because it's made out of two different variations. One is elliptic and the other one is splits. And it's actually one of the most simple constructed fractal flame we can build, but it's also one of the most versatile. And it looks really beautiful and it's simple to do. Let's go in Houdini and do it. Let's create a FLAM3H node. And let's frame it, and let's have a look first how the affine transformation works. So we got the rotation parameter, which take the affine value and rotate them. And let's go actually to the iterator that is responsible for the top part of the triangle. So the O stands for offset, X and Y, so Y goes up and down, and the X, we can move the top part left and right. And then for the X, we got the first value, which is the scale in X. And for the Y, we got the second value, which is the scale in Y. And with those values, we can actually perform all the affine transformation we need. Let's reset FLAM3H and let's add a few iterators for now. On the first one, we are going to add an elliptic split, which is the first one we need to build this fractal. And let's search for it. The menu is in alphabetical order. Here you go, elliptic. Let's get it. And now let's rotate this elliptic by 90 degrees. Perfect. And let's give a name to this iterator and let's call it simply elliptic. Now let's go to iterator 2. And in the meantime, let's call it splits, which is the one we are going to load. And on the active one, let's load the splits variation, which is down there. Here you go. And you can see the name splits and with 3 dots. This means it's a parametric variation and its parameter is populating the vars tab. Here you go, XY splits. And so now we make this twice as big. So we put 2 there and 2 there. And now we go to the vars tab, and on the Y component we set it to 0, and we create splits only on the X component. We can see the fractal is a little blocky, and that's because we don't have enough iteration to resolve it. Let's set iteration to 24, and everything is fine. And now let's set the X split to 1.05, so we are creating a small gap. We can increase the gap and decrease the gap. So we keep it small because that's what we want to do. And now the next step will be to fill those gaps with something else. But first, let's load the palette, which is something I tested before. So this is the library we need. And now we're going to load the palette number 20, which is a little above. There you go. And let's set the HSV value. So the saturation is stronger and the value is higher. So we can see better. And now let's play with the location and the speed. Location is the location of the color in the palette, and speed is how much this color propagates through the iteration. I have some value that I tested before, which I'm gonna enter that now. So 1 for the location and 1 for the speed. And you can play yourself and see how that affects the flame. And let's do the same for the elliptic variation. So 1 for the location and 1 for the speed. Perfect. This is exactly what we want. And so here is the menu showing up the name we gave them before. And so now what we need to do, we have to create another iterator, and we use this to fill in the gap created by the splits variation. So let's get a cylinder and let's rename this iterator cylinder, in this case 01. We will rename it later. And since the splits actually created a gap of 0.05, we need to make the same value for the weight of the cylinder. And since the cylinder is a count from half and half, we need to make it half of that, so 0.025. And now let's lower the probability for this iterator. Since the cylinder is a small bit, we don't need that many points, and let's increase the weight of the iterator for the splits and the elliptic so we can give them more points. Now we need to move this cylinder inside this gap so we can fill all the rest iteratively. And to do that, we need to use the post-affine. Let's go on the cylinder iterator, and we can see that if we are using the pre-affine, nothing happens. But if we do that with the post affine, we can actually move it, and let's set it to 1.025, which is exactly what we need to bring the cylinder there. Perfect. So now it's filling the gap perfectly. Let's make the cylinder longer, setting 10 on the Y component. And now what we need to do is another small bit, since if we are zooming it in, we see that there are some noise inside there. So let's clear up that and let's blur the entire surface of the cylinder with a pre-blur, so we have a flat string going everywhere. And now let's create the second cylinder, and let's go on cylinder number 3, iterator number 3, and let's click this icon, and this icon will mark this iterator for being copied. We can see this is unmarked, and now it's marked. And if we go on the mini menu next to it, it's telling us that this iterator is marked for being copied. Let's go on the iterator 4 and copy the value inside here from iterator 3. Now there is only one thing to do. We have to invert this value so we can fill the gap on the left. And so let's go on iterator 4 and go inside the post affine. Yeah. And now let's put a minus in front of this value. And this will go exactly on the other side. Perfect. Now we have pretty much our elliptic split flame constructed. Let's play with the location and speed of the shader for the cylinder. I have already some value that I'm going to put in. So 1 for the speed, here you go, and 1 for the location, here you go. And now, since iterator 3 is already marked for being copied, let's go to iterator 4 and paste the shader value. Perfect. So now they are both the same. And now there are one more things to do. Well, first of all, let's increase the saturation so we get more color out of it. And now we have to add a final xform, which will take the combined result of everything happening inside the flame tab and deform that one more time. So let's finish this, adding the proper name. So this is cylinder right, and let's copy paste this from 3 to 4 iterator, and let's call this iterator left, so we have something to keep track of what we are doing. Perfect. Now let's go on the FF tab and activate it, and from the var tab, the active one, let's choose a Mobius variation. Nice. It's already looking very cool. So let's play with the offset affine in the pre-affine of the FF until we get something we like. Something like this, more or less. Very cool. Let's check off the tag which was in the way. And now let's set the point count to 15 million so we can review this fractal flame better. Let's go to the preference tab and set the size to 0.4 so we can have a better and precise viewing. And here it is, it looks really, really great. Now the Mobius variation is a parametric variation, so its parameter is populating the FF vars tab. Let's set 0.5 there so we can skew it a little more, which I like it better. So you can see the Mobius has 3 dots, its name is 3 dots, ending with 3 dots, that means it's a parametric variation. Nice, so now we need to render this frame using Karma. So let's lock the parameter window and let's go into stage and create a FLAM3H USD node. Great, and this is importing directly the first FLAM3H node defined in SOP context. Let's activate the denoiser, the NVIDIA optic denoiser, and let's set the width to 0.2. Great, so now also on Solaris we got this fractal flame properly set up. Now let's set the point count to 50 million so we can have more points to describe the shape of this flame. Take about 5 seconds on this machine. Very great. So probably let's reduce a little bit the point scale. So from 0.2 to 0.115 sounds about right. And then let's go to the CP tab and increase the value of the HSV value so we can pump up the color a little more. There you go. It's looking really great. Perfect. We're pretty much done. And this is the classic elliptic splits build inside Houdini using FLAM3H.